This video was made possible by CuriosityStream. When you sign up using the link in the description, you'll also get free access to my own streaming site, Nebula. Where is the highest place that you can climb up to on Earth? This simple question has been around with us for thousands of years, and the answer has always evolved over time as our understanding of the planet has gotten better and better. The answer to the question that probably immediately jumped into your head, however, is Mount Everest, which by every appeal to common sense is the tallest mountain in the world, and therefore is the highest up that you can get to anywhere on the planet while still standing on the surface. But any answer to this question can get significantly more complicated depending on how you phrase the question, and there can be other answers besides just Everest. Here's what I mean. Most measurements of height across the world are expressed in distance above the mean global sea level. New York City, right by the sea, is only 10 meters above the sea. Located further inland, Denver is over 1.5 kilometers above the sea level. Machu Picchu is nearly 2.5 kilometers above the sea, while the summit of Mount Everest beats everything else out at precisely 8,848 meters above the sea. Nearly every measurement of height across the world is done in this way, and by that metric, Everest is indeed the highest up you can possibly get to. But there is another way that you can measure height on Earth: distance on the surface above the Earth's center. As in, if you were stuck in the center of the Earth for whatever reason, how far up could you climb up in any direction that would get you the furthest away from it? If we use this method of height, we unexpectedly get a completely different answer than Everest for where the highest place on Earth is. And here's how. While Earth looks like a sphere, it isn't really upon closer evaluation. Earth's true shape is more akin to an oblate spheroid, meaning that it bulges out slightly more across the center than at the poles. The reason why Earth is like this is because it rotates around really quickly, and the centrifugal forces from that rotation push the shape of the planet out around the equator. So as a result, an object sitting on the equator will be 22 kilometers higher up from the Earth's center than an object sitting on one of the poles would be. Now of course, mountains, hills, and valleys exist all across the planet that affects these heights beyond the Earth's center too, but they don't really play as big of a role as most people think they do in the grander scheme of things. Everything above the Earth's crust can be imagined as the planet's surface with a little bit of water filling some of the deeper parts up. With that in mind, let's take the difference in height between the deepest point on Earth's surface above the crust, the Marianas Trench, and the supposed highest point at Mount Everest. The difference between the two is 19,759 meters, which is only 0.003% the same as Earth's radius. So there's really not that much variation in elevation on Earth's surface compared with the fuller size of the planet. So with that in mind, let's take a closer look at Everest. Everest is 8,848 meters high above sea level, but with a location of 27 degrees 59 minutes north of the equator, and therefore north of the equatorial bulge of the planet. The summit is located 6,382 kilometers above the Earth's center. Further back towards the equatorial bulge, however, we can find a lot of points on Earth that are actually higher up than this. It's just that the entire continent of mainland Asia is actually located north of the equator, so none of the mountains here get that big of an underground boost. On the other hand, the equator actually does pass directly through South America and right through the Andes mountain chain, which is already the largest mountain range found anywhere outside of Asia. A lot of peaks around the equator here in the Andes are actually higher up from the center of the Earth than Everest is, because the bulge gives them a few extra kilometers underneath as a sort of handicap. Let's take Mount Chimborazo in Ecuador as the prime example of this. Measured by sea level, Chimborazo is already pretty impressive at 6,268 meters high, which is higher up than any other mountain in Africa, North America, or Europe. But it's a substantial 2.5 kilometers lower than Everest is. However, owing to Chimborazo's location only 1 degree and 28 minutes south of the equator, it gets a pretty substantial boost in height from the Earth's bulge. The summit of Chimborazo, therefore, is 6,384 kilometers above the Earth's center, which is 2 kilometers further away than the summit of Everest is. This means that as measured from the center of the Earth, the summit of Chimborazo Chimborazo is the highest up you can possibly get anywhere on the Earth's surface. This also means that the closest you can get to the moon anywhere on Earth's surface is at the summit of Chimborazo, and not Everest. In fact, there are several mountain peaks in this area of the Andes around the equator that are all higher up than the Earth's center than Everest is. And Everest itself isn't even technically the world's tallest mountain either. Tall and high have very different meanings for one thing. Tall is a measure of how physically tall an object stands, while high just means how high up in elevation an object is. For example, let's take a 2-meter tall person at sea level and a 1-meter tall person on top of Everest. The 2-meter person is distinctly taller than the 1-meter person, while the 1-meter person is distinctly higher up in elevation. Keep that in mind, and let's compare Mount Everest with Mauna Kea in Hawaii. If you measured both of these mountains based on their elevation upwards from sea level, you'd see that Mauna Kea is a puny 4,207 meters high above the water, compared with Everest's mighty 8,848 meters. However, if you somehow remove the water, you'd see that the base of Mauna Kea is in fact much, much bigger than what it seems at first. That's because 58% of Mauna Kea is actually underwater, so from base to tip, it's actually a whopping 10,200 meters tall, compared with Everest's unchanged and now seemingly puny 8,848 meters. So Everest is certainly not the world's tallest mountain, and depending on how you're measuring things, it's not even necessarily the world's highest mountain either. Now, if you've made it this far watching, then you probably love RealLifeLore, and you've probably already heard all about CuriosityStream, the documentary streaming service with thousands of videos on mountains, volcanoes, and lots of other very tall things. But thanks to CuriosityStream, when you sign up for them now, you also get access to Nebula, a streaming service made by educational creators like me, where we can publish our original, thoughtful content without fear of getting demonetized or buried by the dreaded algorithm. By signing up for CuriosityStream and Nebula, you are directly empowering me and dozens of other educational creators to make cool, exclusive content that we might not get the chance to make otherwise. Content like all of my own RealLifeLore videos that go up at least 24 hours early before they do on YouTube, and all without any ads or sponsorships. And exclusive content like Money, a game show hosted by my friend Tom Scott and featuring a bunch of my other creator friends in a series of psychological experiments that test their willingness to work together. Best of all though, CuriosityStream is offering Nebula subscribers 26% off just for you. That's 2 fantastic streaming services for less than $15 a year. So go ahead and sign up by using the link in the description or by going to curiositystream.com/realliflore, watch cool content, and support creators by watching stuff we've made just for you. Everyone wins, and as always, thank you for watching.